Someone's nicked off with the thing that attaches, so I'll be doing this rooted in place. This is lecture 2 for week 2. Lecture 1 I recorded, earlier, so make sure you have a look at that. And yeah, is there any questions from the material from that lecture? Has anyone watched it? I definitely haven't. Was it great? You're okay. It's okay to say it was crap. So yeah, if you're sort of struggling with some of the material, make sure that you catch up with that. At least the code as well that we did. You might notice that there's a lot of content squashed into this course, so it's important to keep up. Because really after today, we're just 20% of the way through, and we've covered a lot of ground. Okay, so just make sure you show up to your tutes and your labs, keep up to date with the material, and let someone know if you're having trouble. All right, so help sessions start next week, and we'll be releasing the schedule soon. So you'll have to book into those. Really, it's important. It's like medicine. If you notice something, then it's best to get it early. Same with if you're having trouble, get there early, because it'll kind of all flow ahead before you can catch up. This week, we have a revision session today between 6 and 8 p.m. So make sure if you need help, go to that. All the information for this is on the course website. Also ask your tutors if you're unsure. But yeah, try to keep up. I know it's a lot in a short time. All right, so today we're going to recap a little bit on Monday's lecture, looking at data and memory and global variables and pointers. Then we're going to look at one-dimensional arrays, two-dimensional arrays, and then C structures, okay? And that'll sort of lead us into next week. We're going to start looking at functions, and so that's when it gets kind of crazy. So get this stuff solid, and you should be good. All right, so we looked at accessing memory, and so looked at the commands LB, LH, not really LH, I don't think we've used those. Maybe you have in labs, and LW, so LB loading a byte, so like a character, LH loading a half, and LW loading a word, which is 4 bytes, which is the size of an integer. Okay, then we looked at storing data, again, SB storing a byte, SH storing a half, SW storing a word. And yeah, it is just crazy that words are integers and bytes are characters, but that's just how we roll in 1521. So we store and load whole bytes, not bits in this course, okay? So just keep that in mind, where, a byte is 8 bits. And so that becomes important later on. All right, let's recap some of what we did. All right, first thing is this big enough? I think, what did you say, Command plus to zoom? Oh. Wow, okay, that's big. All right, so we have this C program. We've got a global, and we've set it to be 45. Then inside the main of the program, we're going to take one away from 45. We're going to print the value, put a carriage return and return 0. So nothing too scary here. So voila, that's how that works. So in our MIPS programs, or MIPS programs, what we do is we put our global variables in the data section. Okay, so that comes after .data, right at the bottom of your code. And we essentially use a label. So we're going to use a label max so that we match our code. We're going to, it's an integer, so it's a word, and it's got a value of 45. Okay, so that's our equivalent of this line here in the code. Oops, I better comment that out. Okay, so we go into the main here. What we want to do is we want to load the value stored at max, so the label, we can use that to access the memory. Then we want to take one away from that, store it back into max, and then print it out. Okay, so first we're going to load the word into a variable. Okay, whoops. Then we're going to take that variable, we're going to subtract 1 from it. Subtract, and we're going to put it back into T0. So T0 minus 1. Okay, and that's equivalent to our max minus minus. And then we're going to store what's in T0 into max. Okay, now we do the printing part. So remember our v0 variable. So we want to print an integer, so that's 1. And if you're ever like kind of not sure about any of these things, which I constantly am, just after a while you get used to it, but everything that you need is inside your instruction set here. So somewhere in here is the thing that tells you about what the V's are for different printing and reading. So okay, so here, so 1 is a print an int. Okay, so you put the integer, you put what you want to print into that A0, and then it'll be printed in a system call. So that's what that means. Then we're going to load the word into A0 that's in max, and then we're going to do a system call. Okay, so all this together should be right. And then we want to put a character. So 11 is the right one, as far as I can remember. And we want to do a carriage return. Okay, and don't forget to put the system call after it. Okay, and we've got our return to 0 here. So that's our code. And Okay, and it's 44 now. It's a lot of coding for a very unexciting answer, I know. But that just hopefully illustrates how you can access global memory. You know, the common mistakes in this would be, you know, not loading the word, loading a byte or something like that. Another common mistake would be not labeling this as a word, or yeah, not accessing the correct memory, not storing it back, that sort of thing. So it's important to be systematic. It's easy to make mistakes with this stuff. All right, let's look at the next one. All right, so this is, now we've got a global and it's a character. Okay, we're going to subtract 1 from the character, we're going to print it, and we're going to return carriage return. So it's the same thing, but this time we're doing characters. So just for completeness, we'll have a look at the C code, how it runs. Because, yeah. Oops. Okay. So if you minus 1 from Z, you get Y. So now we're going to do this in MIPS. All right, so our character is called X. So we're going to label data X. Now this is a character, so a character just takes up a byte. So I'm going to say a byte, and at the moment its default is Z. Okay, so that's this line here. Okay, so we're going to do very similar to what we did before. So we're going to load the byte into T0 that exists at X. Then we're going to subtract 1 from it. And then we're going to store back into X. I have something in my eye and it's really bugged me. All right. So then we've taken it out from global. We've done an arithmetic operation on it, and then we're going to store it back into the label X. So then we just need to print it out. So this time it's a character we're printing out, so we use 11, not 1. Okay, and then we put a carriage return. Okay, and got our return stuff there. Okay, and prints out Y. So all that makes sense, I hope. All right. All right, so I think at the end of lecture 1, I went through the pointer example, but I'll go through it again just to make sure we're clear with it. All right, so we have a program here. We have a global, and it's equal to 42, the meaning of life, obviously. Then we declare a couple of integers. One, which is just a normal variable I, and then a pointer integer to a pointer integer. So we point the pointer at where the answer is in memory. Then we set our variable I equal to what P is pointing at. Okay. Then we print I. Then we set what the pointer is pointing at to 27, which should change what's stored in the memory, because that's where the pointer is pointing at. And then we print the answer to make sure. So what we're expecting is to get 42 printed out first, and then 27 printed out, if we've done it properly. And, you know, pointer stuff in C is notoriously tricky stuff. It's easy to make mistakes with this stuff. Okay, so this piece of code works well. So let's, whoops. Let's try to do this in MIPS. All right, so first thing is our global. We're going to create the label answer. It's an integer, so it's a word. And we're going to set it to 42. Okay, now we're going to use, just labeled up here, we're going to use T0 as our integer I and T1 as our pointer. So the first thing we do is we point the pointer at the memory location. So we're going to load the address into T1 where answer is, okay? Then we're going to load the word into T0, whoops, that's stored at T1, okay? And then we're going to print that out. So printing an integer, and we just have to move into AO what's in TO, right? Because we're printing I. And we want to do a carriage return. Okay, so now we want to do the next part. We want to change the value where P is pointing at. So I'm going to firstly just use a temporary value and load 27 into it. And then I'm going to store the word that's in T2 into where, T1, that's where the pointer is pointing. Okay. Then I'm going to print everything again. I'm going to short circuit things a bit so that we can. So we don't need move. What we need to do is we need to load the word that's at answer. Oops. Okay, and then we print a carriage return. so let's just check it. We have T1 is our pointer. So we're going to load the address of answer into T1. Then we're going to load the word that is at that address into T0, so that's our I. Then we're going to print an integer by moving what's in our register T0 into A0. Okay, then we carriage return. Then we're going to get a temporary variable and make it equal to 27. And then we're going to store that in the address that T1 is pointing at. All right, then we're going to print the answer, another carriage return, and then return 0. So hopefully that works. Okay, it worked. Common mistakes, and these are me, so you guys might be awesome and not make these mistakes, but one of the things I do a lot is forget to put the T's. And because like a $ number is actually a register in this thing, it's really hard to find them sometimes when the code gets big. So it's worth doing line by line checking. And sometimes when it gives you absolute garbage, you kind of like, you can sort of go, oh, okay, there must be one of those errors somewhere. All right, so did that make sense to everyone? Is that all kind of clear? As I said, you know, in the first lectures, this stuff is super tedious, and there's a lot of very specific things that you need to do, so it's important to be really sequential, do things step by step. Especially next week, we get into functions. It's really important to be really logical with your step making and that sort of thing. Okay, so what we've done so far, and this is kind of a useful cheat sheet, this slide. So the .text, everything after that is where we put our program. You always do need a label main. I discovered that, and it sort of crashes and gets mad at you, so always have a label main. And that obviously is really important once you do functions. Then data is where you put all of your globals and parts of memory that you want to sort of keep for the entire program. And as you've seen in the last few examples, it allows you to access that memory, read it out, store new things into it so that you can keep track just like in a normal program. Now, the types of things we can store in memory, so we can use .space to just create space, so initialize some space for, say, a character array, okay? We can use align to make sure that we keep that 4-byte address. So remember, to access integers, you need an address that's divisible by 4. And given that we're very kind of analog with how we deal with memory here, it's important to keep track of that. So if we allocate a space of 18, that's not divisible by 4, so we align 2, so we have a little bit of space so that we can have an integer after that. So we can declare a single integer like we did in the last example. Remember, we're using 32-bit integers here, not 64. And so that's just making a variable I equal 42. We can also create an array of integers. Or we can specify that they're halves, right? So they're not using up as much memory, so just 2 bytes instead of 4. We can declare an array of characters, bytes. So this would be 8. So this is an integer, but it's an 1-byte integer, and it just fills 5 spaces with that character or number. That's kind of handy to initialize arrays, say, to 0. That can be really good. We don't use floats in this course, so you won't have to worry about this one. We use this a lot to make messages and directives. So ASCII Z gives you the null character at the output, and then ASCII just gives you basically a character array. And so both of these are useful, but when you want to put a directive out there or a message in a system call, then using the null terminated is the way to go. So when we're looking at initializing global arrays, as I said, we can just create space. We can put a list of numbers. We can create an initialized array of numbers or characters. A string can either be done with single characters, or we could do it with ASCII. So this is easier than this, just in terms of typing. So then the question is, how can we access all this? So we know that when we make a declaration like this, so V, that's our memory address is at V. We have this whole array. So how do we access each element of that array? Okay, so here we've got a character array with all these characters. In C, we access it by putting an index number. So once we have the start of an array, we should be able to see how we might access elements within it. Okay, so if we want to access A3, and we know that the whole array starts at 100, then we know that that's 3 elements along, so we can add 3 to it. And similarly, if we wanted the ith element, then we could access by adding I to that memory address. Okay, so integers are different, right? So they take up 4 bytes of memory. So every single iteration to the next index is going to be like +4. So we're going to be constantly adding +4 to it. So the summary of this is that if you know the start address, which you do in MIPS because you've put a label there, it's going to be that address plus whatever index you're looking to find, okay? For integers, it's going to be the start address plus 4 times the index, because we need to move in steps of 4 bytes. So in general, for one-dimensional arrays, you're going to be, in order to access an arbitrary element in an array, you're going to have to get the start address of the array and then add 1 times the size of the element. So this generalizes it. So the size of the element in a character is 1. The size of the element in an integer is 4. Okay, so accessing elements in MIPS. All right, so this is one I've created earlier, as you can see. So let's go down the bottom so we can have a look what we've got. We've got a character array, and we have an integer array. So let's see what this does. All right, so let me just pull this up so we can see. It's accessing particular elements in those arrays. Just want to bring up the C code. So we're going to access the first character in the character array, the first integer in the integer array, and the second in the character array, and the second in the integer array. Okay, so we should see K8 C5. So this code has been done character array followed by integer array. So we load the address, okay, into T0. So now we have where the character is. And then we load, here we put a 0 to say we want the 0th element, or 0 plus the address into T1, and then we print that out. Okay, so because we've loaded it into a register, we just have to move that into A0. Okay, then we add 2 to T0. So T0 was the address of the character array, and now we want to add 2 to that. We load that address, the byte at that address, and then we print that out. And then print a return carriage. So for the integer array, we load that address into T2. We load the words at that address into T3, and we print it out. Okay, then there's 2 ways of doing this. You could add 8, so that's 2 steps, so 2 times 4, right? We need to make steps of 4 with integers. So you could just manually do that so that you have a sanity check, or you could just say that you want to move 8 addresses across. Okay, so both of these would be fine. Obviously, you wouldn't have the add I. You'd just have a 0 here if you did that. Obviously, doing it this way is less lines of code, but you know it's a shortcut. So make sure you know use it properly. So then you move that value into a 0, print it out, and yeah, that's that. So you can see it's not super difficult to access arrays. It's just really important to know what kind of value. Yeah. Yes. So if we were to do it this way, we'd want to do that. I think that's right. Yep. So yeah, it needs to be changed. Sorry? Well, yeah, because we're loading from whatever was T2 plus 8. Yep. No, it doesn't. No. So we don't need it here. It's just for illustrative purposes. But if we wanted to, if we had T2 the way it was before, which was the initial address, then putting the number here says how much we're adding to that address. Yes, T2 hasn't changed. Yeah. So up here, when it's still my int array, so I haven't touched it. And so it's now my int array plus 8. All right, let's do a couple of coding examples. All right, so we have this piece of code. We can see that we've got an array that's defined with hello. We've got a for loop here, and we're just going to go through the array and print out each character in that array, okay, and then put a return carriage after that. Now, just because we haven't done this all day, let's just wait. All right, let's do the simplified C. So if you remember from last time, when we have a for loop, oops, that's one I created earlier. When we have a for loop, we can simplify that down so that we can go line by line with our C code and line it up with our MIPS code. All right, so let's do that. Okay, so we've got a for loop here. Often we change it into a while loop, but let's see if we can go through and change this up. So I've kept everything else the same. So the global is the same, the definition is the same, everything else in the program is the same. We're just going to take this for loop and we're going to split it up using our very terrible go-to, don't use it anywhere else. This is the only class you should ever use it in. Please don't destroy the world with go-tos. So the first thing we do is we do the condition. So we've set our integer, our index to 0. Now we're going to have something that we'll call loop condition, and that condition is going to be if I is greater than or equal to array len, then we're going to go to loop end, okay? So at loop end, what we want to do is we want to put a character and the return, so we can label this now. Okay, so if that condition doesn't hold, once I is greater than array length, we're going to jump to the bottom of the code here, put a character, and then return. Okay? Now, if the condition is, if the condition is met, then what we want to do is we're going to put the character at I, and then we're going to iterate I. So we're going to iterate. Okay, common to forget this part, we need to go to the loop condition again. Okay, so hopefully this does the same as the first one. Let's look at the first one. So okay, prints out hello, that's good. Now if we, this has a very long name, simple class. Oh, okay. So that wasn't too crazy. And, you know, for some of these simple things, you can just jump ahead and not worry about going through this step. It's just, it's good to get in the habit just to learn how to pull out a for loop, and once you've got it in your head, you don't always need to do it. All right, so now we're going to create a MIPS file that does the same thing as this. So one thing that we can do is just declare a, well, not declare, but just sort of give a name a value. And this really helps. You just create a list of all the values you want to use inside the code, and then you substitute with the name so that you can change it easily and it's easier to debug. So this is actually very useful. So you put it above text because it's not really part of the program, it's just doing a substitution. And then we have our global that is called array. So there's a couple of ways I could do this. I could do it by saying, you know, byte and then doing a whole list, like, you know, this. Or I could just declare it like this. It's not an ASCII Z, so it doesn't have the null character. But this is the same as a character array with a lot less writing things. Much easier to type this. So that's our character array. Okay, so we're gonna load into T0, 0. So that's our I, so T0 will be our I. Then we've got our loop condition. Okay, so branch if greater than or equal, right? T0. So we want to branch if it's greater than or equal. So it's this line here to arraylen. Okay, and then we want to branch to something called loop end. Okay, now loop end doesn't exist, but past me created the carriage return and the return to 0. So we don't have to type that. All right, so let's say the condition isn't met, so we keep going through the program. So then we have, this is the loop body. Okay, so we want to put char array I. So firstly, we need to, so we can do this straight up, right? So we could go load v0, we're printing a character. We can load the byte from into A0 and oops. Okay, so we can load the byte at array plus T0. And we can do a system call, and that should print our character at I. But we need to now add 1 to I. Okay, and then we need to branch to the loop condition. Okay, so let's see if that works. Array, its indexes, class, that is. Hello. Okay. So we could have loaded loaded the byte, well, loaded the address, you know, into a different variable. We could have then added, you know, we could have added to that, and then we could have loaded that into A, but this is a shortcut way of doing it, which hopefully makes sense. It lines up better with your C code as well. Okay, so the other one is an integer. So this one, we just need to add 1 to move to a different address to print out each character. For an integer, we'd need to add 4 to access an integer array, because an integer has a size of 4 bytes. All right, so here we have a integer array with a bunch of numbers, and we want to we want to print out. It's essentially the same thing, except we're putting a space between each number, because with the characters we kind of wanted them to push together and create a word. With the integers, we want to see each value. Now, rather than go through the simplifying again, I have created one. So let's look at this. So this is we've got a for loop here, so we've pulled it out. So we've got the opposite of the condition. So if the array length, if we go beyond the array length, we want to jump to the end. Okay. Otherwise, we're going to print the value, put in a character space, and then go back to checking the condition after we iterate the index. Okay. Let me just okay, so it's just printing all the elements of this array and putting spaces between them. That's what the program does. So there it is. Okay, so I've added in the array just to save time. So that's that array. So remember, with words, we can separate each element with a comma. And since they're all different elements, then that's how we've done it. We can create our label for array length, which is also 5. Okay, so now what we have is, again, we want to initialize T0 as our index value. So we're going to load T0, 0. So that's going to be int is equal to 0. Then let's put our label down, loop condition. Okay, so if, not if, a branch, if greater than or equal to T0 array length, and then we want to jump to loop end. Okay, so this is the equivalent of this line. Okay, greater than or equal, we want to go to loop end. So loop end is here. Okay, So if the condition isn't met, then we're going to do the things in the body. All right, so we want to print array I. Okay, so we know that we want to jump by 4. So we take our index I and we multiply it. Okay, so let's use T1 and we multiply what's in I by 4. Okay, so if it's 0, it's just going to be 0. If it's 1, it's going to be 4, so that we iterate by 4 steps every time. What do we call it? Array. Okay, so we're going to load the word into A, that's A0, that is the memory location array plus T1, okay? Okay, then we're going to put down a character. It literally is getting the two speech marks and putting a space in between. Okay, so the next thing we need to do is iterate T0. All right, so we're going to add, and then we need to branch back to the loop condition. Okay. Oops. Okay, so this lines up pretty well. We've got I is equal to 0. We've got our if I is greater than the array length, then we're going to go to the end. At the end, we're putting a character and returning 0. If the condition isn't met, we're printing the value of the array at the index, which jumps by 4 in the case of an integer. Then we're printing out a space, adding 1 to our index value, and then we're looping back to check whether we've breached that condition. Okay, and they see it prints out our array. I think this is a good moment for us to stretch our legs and take on fluids, and we will return in a few minutes. All right, let's get back to it. Okay, so so in C, when we add 1 to a pointer, it'll increase it by the size of the type that it points to. Okay, so it kind of does all this automatically, so you don't have to think about it. So if you've got a pointer of type char, then when you iterate that pointer, it goes up by 1. Okay? For an integer, when you iterate, so we've got an address here or value here, we iterate it, it goes up by 4. For a double, it goes up by 8. I imagine for a half, it goes up by 2. But it automatically does it so that you don't have to think about it. So in MIPS, we have to think about it ourselves. We have to think, oh, that's character, so we're going up by 1. Or, oh, that's an integer, so I need to go up by 4, and so on. Let me just bring up. Incidentally, there was an update, which I haven't pressed the update on VS Code, but there was an update that for some time broke the MIPS plugin, but apparently it works again. So if anyone's had any problems, maybe update things. I always use the command line to use MIPSy, so I don't, unless I want to see the values in the registers or the memory, I don't actually use it. But if anyone's had any problems with it, make sure you mention it to your tutors because they'll be able to help you update it. It apparently all works now. So I was just too scared to update in case everything broke. So I guess I can now. All right, so we've got this piece of code. I should... Is that a good size? Yeah, maybe. So we've got an array, hello, and we're just printing out all these sort of parts of it. So we're printing out array index value, right? It's in a for loop, so it's going to print each one. Is equal to array I is equal to I array and star array plus I. Okay, so let's just run it so you can see. This is just showing you all the different ways that you can access a value in an array for a character array and for an integer array. And you can see that we're just iterating here. So automatically the C compiler is going, oh, it's a character, I'm adding 1. It's an integer, I'm adding 4. And it does it really seamlessly. Okay, so firstly, it's telling you where the array lives. It's saying that the first element is H and that all those different ways of accessing H work. Right, so we have I is that one. That's just the index. Then we've got array I array, and star array plus I. And that all those ways of accessing the array work. Then we show what the address is. So the address at 0 is the same for all of these different ways to access it. Okay? Some of these you would not generally use. It's just showing that there's a multitude of ways to show the same thing, right? So as we iterate through the array, we can see it's a character array, so we're iterating through the memory locations here, okay? Just moving 1 byte at a time. when we look at array 2 is an integer array. So it, again, all those different ways work. And we can see when we go look at the memory addresses, they're going up by 4 every time. Okay, so that's just how things go in C and how it makes it easy to do things like accessing different kinds of elements in an array. But we in MIPS always have to take this into account. Okay, so that's one of the things when you're translating between code, and I guess I skipped over it a little bit, but you know, an I++, when it's a byte that you're trying to access versus an I++ when it's an integer that you're trying to access, you need to do that extra step in order to make it go up by values of 4. Okay, so we have a style guide in the website. You know, experienced programmers use pointer arithmetic to make nice code. It's important that you kind of write your code at the level where you understand it. I'm always a big fan of writing as much down as possible until it's in your head. Unless you're programming MIPS or C every single day of your life, and in that case an expert programmer, it's easy to make mistakes. It's easy to forget how to do things. And I think that's kind of what this is trying to say. Make sure that you make the code understandable to you in the first instance while you're learning. As you get more and more expert, you start making shortcuts. But you'll find, like this course, you know, we finish up sometime in August. By September, if I kind of pulled you up at the cafe and I said, write me a MIPS program to access an array of integers, you'd be like, that has completely fallen out of my head. I've got no idea. It's not going back in there now. So it's one of those things. Practicing something makes you kind of, I guess, a little bit lazy at times, and then later on, if you need that information, if you haven't been very precise in how you've documented things or how you've understood things, you may not be able to access it as easily as you could have in the past. All right, so these are just some codes, just basically showing you how pointer arithmetic works. So in this particular case, we're pulling a array, so we're writing something, we're pulling that out. As long as we're not getting to the null character, we're going to print out what was pulled out by iterating our pointer along each element of the array. Here's one I prepared earlier. So what we expect we're going to find is that whatever we type in should be printed back out to us. So let's see if that is true. Okay, so I've got to print something. I mean, really, it would be better practice to give a prompt. Okay, so I've just typed something and prints it back. Not very surprising. The thing to note here is how we're using our pointer. Okay, so we're declaring a character pointer that's pointing at array, which is what we've just read in. And then we're printing out which element in that array by moving the pointer. So this is stuff you would have learnt last term. Instead of using a index, we're now pointing at the whole array, and we're moving the pointer into each different memory address. Okay, so similarly, here we've got an integer array. We're going to point to the first value. And we're going to point to the last value. And then we're going to, again, as long as the pointers aren't pointing at the same place, we're going to print out a value, put a character, and then iterate on the pointer. Okay, so iterate the address that the pointer is pointing to. And that's the key here. The pointers are pointing at something in memory, and as we iterate the pointer, it changes which address it's pointing at. It doesn't understand things. What did I do? Okay, so it points to, it starts off pointing at the first element, right? Then we iterate it, it points at the second element, and so on, okay? We know in MIPS we'd have to iterate by 4, okay? But here it does it automatically. And if we changed, you know, where we want to end up, right? If we point to the value at 3 in the array, then we're going to print out only up to that value, okay? So, yeah, basically using pointers to access elements of array instead of using the indexing. And it's essentially the same, but it's different because we're iterating the memory address, not the index. Okay, so that was us playing with one-dimensional arrays, and it was pretty straightforward, right? We just needed to know the address location of our array, and then we could just iterate on that depending on whether it was a character or an integer. Now we you know, delve into the fun land of two-dimensional arrays, okay? So here we have rows and columns, okay? And in reality, this is how real physical memory is set out as well, okay? It's set out as, it's not just a big long line, it's set out as blocks of memory that we can access, and that is a two-dimensional array for all intents and purposes. So we need to be able to map to a two-dimensional array somehow in our MIPS program. And so we have 2 indices, and then we need to work out what's the appropriate offset. So if we take this two-dimensional array and we stretch it out in memory like this, then we should be able to access all these elements by working out how this array gets stretched out. Okay, so if we wanted to access A1, so these are the rows, so E, or, so what would be the offset for E? So it'll be all of the columns plus the row, yeah? And if we wanted to access, so 2, 3, L, then we'd have to say, okay, we've got two rows, and then we want element 3 in the last row. So anyway, it does your brain in trying to work it out. there is a formula for it, which we'll get to. And if it's an array of int, then each one of these steps is actually 4 bytes. So we also need to take that into account as well. Okay, so offset of start of relevant row. Okay, so the row, so whatever row value we want, times the number of columns, and then times the size of elements. And then the offset within a row would be the column times the size of elements. So let's just think about this for a sec. Say I wanted, say I wanted E, okay? So I need, what row is it? It's row 1 times the number of columns. So we've got 4 columns here, so 1 times 4. And then the offset within the row would be the column. In this case, it's 0. Okay, so that would get us E. Okay, so if we wanted K, we want 2 rows times the number of columns, which is 4, 8. Then we want to offset it by, what's the column? It's 2. Okay, so then we would get to 10. So we'd be at 8 after this, and then we get to 10 plus 2 from this. So altogether, what we do is and this kind of starts to burn into your brain after a while, you take the row index, you times it by the total number of columns, then you add whichever column index you want to go to, and you multiply it all by the size of the element. So if it's a character, size is just 1, great. If it's an integer, size is 4, so you need to multiply by 4. All right, let's look at a couple of examples. Okay, so flag.c is just a it's just characters that we're printing out. So let me just pull up everything we're going to need. All right, let's look at flag.c. So we've defined number of rows, number of columns. You don't always have that luxury, but if you do, it's a good thing to add that. Then we've got our 2-dimensional array, okay? It's a bunch of hashes and dots, okay? Then in our C program, we just have a for loop. So we're going to iterate the rows, and we're going to iterate the columns within that. So we're going to go row is 0, then we're going to do all the columns in that row, okay, get to the end of that, and then we're going to iterate the row again, go to the next row, iterate through all the columns, back again. So that is okay, so amazing graphics of the 80s. That's what we're printing out. So we know that to make things simple, we could instead change this into a while loop, which is essentially the same, except we have to declare our integer and iterate around it. I'll just use that to refer to, but I put it in there so that you guys have access to the while loop for it. So I'm going to go through the simplified case, not because I want to torture everyone, but mainly just because here we've got 2 loops. So we've got 2 nested loops. It's easy to get confused where you are. So let's try to sort this out, right? So I've just declared my 2 indexes, row and column, and then I'm going to break my for loops and stretch them out using ifs and gotos, right? So the first loop row, and you know, it's good to label things. So the first loop row condition is if row is greater than or equal to number of rows, okay, then we want to go to loop row end, okay? So once we've finished all of this, we actually don't want to do anything. We just want to return 0. So we're just going to come down here. Okay, if that condition doesn't hold, what do we need to do? Okay, so we need to set column equals to 0, right? So the while loop kind of pulls it out a little bit better. We inside this loop, we set that inside that loop, and then we jump into this next loop. Okay, so we're going to make col equal to 0, and then we have the column condition. Okay, so if column is greater than or equal to number of columns, okay, going to go to loop column end. Whoops. Okay, so at the loop column end, all right, we want to do these things here. So because we're printing out this gorgeous designed flag, we want to do a carriage return, and we want to iterate on the row, okay? So we're going to print okay, and we're going to add iterate the row, and then we're going to go to loop row condition. Okay, so when we finish this nested loop, we print a return carriage, we iterate the row, and we go back and check if we've iterated row past where it should be. If we have, we go to the end. If we haven't, we jump back into our column thing. So we reset col to 0, and we check it, and then because it's 0, it will work fine. So we need the loop col body. Whoops. Okay, and this will be, we're going to print, I'm going to print this. Okay, and then we're going to iterate the column, and then we're going to jump back and check the column condition. Oops. Okay. Right, so we're checking how far along we've gone in the rows. If that's fine, we set column to 0. And then we check, is column greater than or equal to the number of columns? If it's not, we print out the next row col, we iterate column, we go back to the column condition. Once we've printed out a whole column, we go to the column ends, we print a carriage return, we iterate the row, we go back to the row condition, and once we've hit row is greater than or equal to n rows, then we go to the end, which is just return 0. All right, and we have our beautiful flag again. Okay, so you can see it's, as long as you're systematic with how you do it, multiple nested loops, not really a big issue. Now let's do this in MIPS. Okay, so I put this in beforehand because this was a tremendous pain in the neck. It's all there. Sadly, there's a lot of things you can't shortcut in MIPS, and writing, I mean, it was an amazing pain in the neck here as well. But this you have to do byte at every row. And anyway, so here it is. This is our variable, our global variable flag. Okay. I've also put our n rows and our n cols up here. So now we can start. Okay, so this is obviously very easy to get wrong. So having the simplified code and following it through is actually, that's one of the best parts of the simplified code. So we're going to make T0 is going to be our row, okay, and T1 is going to be our column. Now, I don't actually have to put this line up here. It's really just to line up with the code. So one thing with the DCC compiler is if you declare an int inside a loop, it gets mad at you these days. It'll still run it. It just says that's very bad, you shouldn't do it, don't do it. So it's kind of trained me not to do that anymore. But it's not a huge deal. But putting this at the top at least allows us to keep track of which label we're using, which register we're using for which indice. Okay, so now we're going to do the loop row condition. Okay, and that's going to be branch if greater than or equal to T0 number of rows, and we're going to branch to loop row end. Okay, so loop row end in this particular case is just return 0, and we've got that already here, so let's put that in. Okay, so let's say we pass that condition. What do we do next? All right, we're going to load T1 to be 0. Okay, so that's lining up with this. And then we have our column condition. Okay, and that is branch if greater than or equal T1 number of columns, and we're going to loop column end. okay? Now, loop column end is, we're going to print out a return carriage, iterate row, and then go back to the loop row condition. So printing, oh. No, character. So that's printing carriage return. Then we're going to add, our row is in T0. We're going to add 1 to that. And then we're going to branch to loop row condition, okay? So that's what happens at the column end. Column body. All right. So we're going to print what is inside this, this memory. So if we remember, because I often forget. All right. So the memory value, so the offset that we need, will be the row multiplied by the number of columns plus the column that we want to access, and times that all by the size of elements. Now this is a character array, so size of elements is 1, so we don't need to do that bit. But we do need to do row times columns plus columns. So let's create, where's my mouse? There they are. Okay, so let's create a variable T2. So let's start with multiplying, let's call it temp. So T2 is our temp. We're going to multiply T0, which is our rows, with the number of columns. Okay? Then we're going to add T2, we're going to add that rows times number of columns to the columns, which is in T1. Okay? So that now is our offset. So we can go load B0, printing a character, and we're going to load the byte into A0. That is at, what do we call it? Flag. T2, okay, because that has our, oops, see, I made that mistake. Okay, that has our offset value, okay? So it's row times columns plus the column that you're trying to access, okay? All right, so row, whatever row we're trying to access, then multiply it by column so that it's stretched out into that 1D array, and then add column to get the particular column. We're not multiplying by size of element because that's 1, and so we don't need to. And this is very concerning. Hopefully it's lying. Man. Hopefully that works now. All right. Where was I? Okay, so we're loading that into A0, so we can do a system call, so that should line up with that. Okay, then we want to iterate the column, so and then we want to branch to loop column condition. Okay. All right, let's see how we've done. Okay. It prints out that beautiful graphic flag. All right, so the only real, difficult part of all of this, I think, is just remembering how to access the offset for the big array. It's worth sort of burning that into your memory. Otherwise, you can work it out by looking at a picture, but it's obviously not as easy to rederive something in an exam condition or something. All right, so now we'll do a example. This way, I need to sign back in again. Okay. So we will look at print to the int. All right, so this is basically the same sort of game, except now we've got a two-dimensional array of numbers, and we're going to print those out. So let's just look at what that looks like. No. Yeah, come on. We're back. Okay, so it just prints out that array of numbers. All right, so pretty sure I did the simplified already. Good exercise for you to do is to take this code and make the simple code yourself. Didn't want to labor too hard on a point because this is pretty much exactly the same as the last program. All right, so let's make this into MIPS. And I'm sure you know that the most tricky part of this is obviously the fact that now we're iterating by bytes and not characters, right? So we need to jump up by ones. All right, so I've pre-put the word in here. Nowhere near as painful as putting the characters in. And I've put in the definitions for rows and columns. Right, so again, we have our, we're going to have our registers that we want to set to 0. And again, we're going to use T0 for our rows, which is called I now, just to make things fun. And our columns, which is J. Okay, then we want to jump straight into our row condition. So we want to branch if greater than or equal to our row. Is it greater than the number of rows? And if it is, we want to loop to the end. Okay, so if we go have a look, loop where end is just return 0. So we can put that label here. Okay, if we pass through that condition, then we want to set our column index to 0. Okay, then we're going to test our column. Okay, now loop column end is where we just do a carriage return, iterate our row, and then go and check the row condition. So let's put that one in. Okay, so we're printing out, and then we're going to add to our row 1, and then we're going to branch to loop row condition. Okay, so that's what we do when we finish a column. Okay, now we look at what do we do inside. Okay, so here we print the value of the array, and then we put in a space, then we iterate our column indicator, and then we loop around and check the column condition again. So to get this value here, we need to kind of remember our access thing. So we have the rows, or in this case it's I, times by the number of columns, right? And then we're going to add J, okay? And then we're going to times all that by the size of int, okay? So that's what we need to do. Right, so firstly we'll do the multiplication. So we're going to multiply we're going to create a new variable, temp, T2. We're going to multiply T0 by the number of columns. Okay. Then we're going to add going to add T1, which is the columns. Oops. Here it is. Okay. Now, last time we didn't need to do this, but this time we need to do a multiplication, right? So we need to multiply. Okay, so we need to multiply by 4 because that's the size of the integers. Okay, and then the rest of it runs pretty much the same. So we want to print an integer to the output. Okay, we want to load the word. Okay, that is, what have we called it? Numbers. and using the offset that we just calculated, which is in T2. Okay. Okay, so that is our print, so that's that line. And then we want to do another print. We're gonna character. And then we want to iterate J. Okay, so that's going to be add J is T1. And then we want to branch to loop column condition. Okay. So pretty much identical to the last program, actually. The only difference is that we have this offset because of the size of integers. Okay, and as you can see, we printed all the characters out. So, you know, as long as you remember what it is that you're doing, it's pretty straightforward. But it's just creating those good habits is the key thing. We've only got 5 minutes left, but the bulk of the lecture's done anyway. All right, so structures are essentially just grouping together a bunch of things. So we could have 2 integers in our structure, we could have 2 characters and an integer, all sorts of things. And depending on what's inside the structure, that will determine how much memory you need for them. So say we have a structure, it has a student ID, it has a character with your first name, a character with your last name, what you're doing, what you're studying, and then an alias for the student. We can see that we can, with the structure, the word suggested as well, is that it creates offsets where needed in order to make sure that the memory is all properly utilized. So, so for this array, it'll be +4 because we've had an integer with bytes. And then we've got +4 + 20, right? 24. Then we've got an integer, okay, which is 20 more along, okay, so it's at place 44. And then we have a character array, which is 44 along +4, which is 48. So that's where that part of the structure would start. That's the start address, okay? So that's the offsets, and then you need individual offsets within that. So the total size for all of this for alignment purposes would be 60, okay? So remember, we cannot access integers that aren't at memory addresses divisible by 4. So that's why we need alignment in this. Okay, so we will recap on those next time. Worth thinking about them, but that's just your fun introduction. So we looked at 1 and 2D arrays. We looked at loading and storing data and pointers. We briefly looked at structures just then. We will do a little bit more next time. It's not super important. It's really just combining our ideas of sort of arrays, accessing those, and how to structure memory. So next lecture, we're going to look at functions. Any resources, remember the website has all the stuff that you need. Feedback, please provide feedback. Don't forget to use the forum. I can see people are using it, but keep going with that. Any admin stuff, make sure you email. And any help, please seek it. I'll see you on Monday. should read the words.
Yeah.
I'm always like, if it doesn't have pictures, I'm like,
Yeah.
really? You expect me to read this?
I mean, there's some pictures. Some photos.
Yeah.
Alright, we'll have to run off to my tune.
All right.
So,
Well, thanks for that. Was that all good? Was there lots
yeah,
of
it was all good.
good questions? And
Yeah, everyone was a bit quiet today.
oh, okay.